Okay, think about this for a second. What actually happens to all that wood waste from construction sites? Well, most of the time, it's just a chaotic, contaminated mess. But what if you could use AI to refine that mess, to turn it into a clean, super valuable resource for the new bioeconomy? That's exactly what we're diving into today. This is the 95 Wood system, and it's basically a full-stack digital refinery that's designed to turn a liability into a real asset.
So, here's our game plan. We're going to start with the huge problem of wood waste. Then I'll introduce you to this whole concept of a digital refinery. After that, we'll peel back the five layers of AI that make this whole thing tick. We'll look at the powerful engine running it all, and finally, we'll see how it all comes together to transform useless junk into something with verifiable value.
All right, so the entire challenge really boils down to one thing: a massive quality gap. See, on one side, you've got these giant heaps of unpredictable wood waste, and on the other, the high-tech bioeconomy. Well, it needs raw material that's incredibly pure and consistent. Right now, those two worlds are miles apart. And this really puts that gap into perspective. On the left, that's the reality of waste from a job site, right? It's a jumble of different wood types, it's covered in paints, plastics, metals, you have no idea where it came from, and it's probably soaking wet. But the bioeconomy, over on the right, it has super strict rules. It needs feedstock with a verified origin, contamination under 1%, and moisture below 10%. You just can't get from the left side to the right side without a really smart system for sorting and verification.
This is where the whole idea behind the 905 Wood framework is so clever. Instead of just thinking about it as, waste management, the system treats it like it's crude oil that needs to be refined. It's a digital refinery that's built to create order from all that chaos.
So what is a digital refinery anyway? Well, think of it as a software architecture that's built in layers. Each one of those layers uses AI to do a very specific job: sorting, verifying, and, in the end, transforming that low-value, messy wood into a high-value, regulated feedstock that the bioeconomy can actually use. It's refining information and material at the exact same time. Pretty cool, huh?
All right, let's start peeling back these layers so you can see how this system really works. The 95 Wood framework is built on a 5-layer architecture, and each layer handles a totally critical part of that refining process.
And here it is, the full stack. It all starts with the intake module, then moves to logistics. From there, it runs through the regulatory, financial, and reporting modules. And holding it all together at the end is a final scientific validation layer. We're going to walk through every single one of these step by step.
The very first layer is the intake module, and this thing is all about speed and being proactive. It's basically a gatekeeper right there on the construction site. It uses an AI model that runs directly on a mobile device, so it can look at a bin of wood and make a call. Is it clean or is it treated in less than 2 seconds? This is the first crucial filter that decides where that wood goes next. Next up, Layer 2, Logistics. This module is all about managing the physical movement and processing. It uses a hub-and-spoke model, which is just a super efficient way to get waste to local processing hubs. Once it's there, the wood gets sorted, dried, and broken down into these tiny 2 to 4 millimeter chips. And the system is smart too. It talks to truck scales to make sure they're not overweight, and it uses a first-in, first-out inventory logic so the wood piles don't just sit around and rot.
Okay, now this is where it gets really clever. I mean, deciding if wood is clean or hazardous has huge legal implications. So how in the world can you trust an AI to make that call and have it actually stand up in an audit?
Well, the answer is a technique called Retrieval Augmented Generation, or RAG for short. The best way to think about it is like giving the AI an open book exam. But, and this is the key, the only book it's allowed to use is the official legal document, Ontario Regulation 347. This forces the AI to base every single decision on actual, citable law. So it gives you legally defensible reasoning, not just some black box guess.
The financial layer uses these really smart incentives to get everyone to do the right thing. So instead of a flat fee, the system has these dynamic CIRCIL levies that can range anywhere from $5 to $60 a ton. Here's the kicker. If a client sends a load of clean, nicely sorted wood, their levy is low. If they send a contaminated mess, that levy goes way up. It creates a direct financial reason to be part of the solution.
But hey, it's not just about penalties, it's also about rewards. For every ton of dry, clean wood that gets processed, the system can generate about 0.75 tons of CO2 equivalent in what are called carbon dioxide removal certificates, or CORCs. This money is then shared back with the client as a carbon dividend.
All of a sudden, their wood waste isn't a cost anymore. It's actually a source of income.
And finally, we get to the scientific validation layer. You see, a standard phone camera is pretty good, but it can be fooled. It only sees surface colors. For example, pressure-treated wood that's been out in the sun can look identical to old clean wood. That's where these advanced sensors come in. Near-infrared, or NIR, can spot the hidden chemical signatures, while XRF sensors can actually detect the heavy metals, like arsenic and chromium, that prove it's hazardous. This is the final, non-negotiable quality check.
So we've seen what the 5 layers do. But for a system like this to be trusted by regulators and big enterprise clients, it needs an industrial-strength engine. That's where the MLOps Foundation comes in. This is all about building a system that's reliable, totally auditable, and ready to scale.
At the very heart of this foundation is a tool that's basically the system's indestructible black box recorder. Every single time a decision is made, it records everything. Which version of the AI model was used, the exact data it was trained on, what parameters were set, everything. It creates a permanent, unchangeable digital receipt for every single action.
And this is why that matters so much. It creates a static graph of all factors. What that means is, if a regulator shows up a year from now and asks, hey, why was this specific load of wood called clean on this exact day? The system can instantly recreate the entire digital environment and the logic that led to that call. That, right there, is the definition of being audit-ready.
Now, this powerful engine isn't just one program, it's a whole suite of integrated, enterprise-grade AI tools working together. You've got one tool that automates the entire workflow from start to finish. Another one provides incredibly fast database searches, up to 10 times faster, which is what you need for that legal reasoning system to work in real time. A third tool handles data governance using a policy-as-code framework, setting the rules to ensure data quality. And finally, specialized observation tools are constantly watching the AI models for problems like data drift, to make sure the AI's performance doesn't slip as the seasons change how the wood looks.
So, after all that processing, after going through all those layers, what's the final result? The system takes that chaotic, worthless input and transforms it into multiple streams of verifiable, documented value.
This really lays out that whole value chain, from waste to asset. First, the AI verifies the material. Then the system automatically generates all the audit-ready compliance reports. Based on that verified data, it calculates the carbon dividend for the client. And here's the real game changer. It gives the client verified Scope 3 emissions data they can use for their own sustainability goals. What started as a costly disposal problem has now become a documented, revenue-generating environmental asset.
So, there you have it, the 905 Wood Digital Refinery. It's just an incredible example of applying a full-stack AI architecture to a really messy, real-world problem. And it leaves us with one last, fascinating question to think about. If AI can do all this for wood waste, what other traditional linear industries are just waiting for their own digital refinery to help them go circular?